the relationship between boiling point and molecular mass. So we are going to talk about boiling point in this one, and also the molecular mass. Molecular mass is nothing but molar mass, by the way. So this is molar mass. It's that number that you can grab from the periodic table. So that's what we are given of aldehydes. You should remember what aldehydes look like. Anyone who remembers the functional group of aldehydes, how do we represent it? C and because functional
I think
groups are important. Yes.
is it CO8? No. C.
Yeah,
Wait. I think the double bond is O. Then you have an H. C double bonded O, then an H.
Okay. Do we have a question from someone else or a comment?
no, I wanted to add on what the Papa was saying. Yeah,
Oh
what you
yes.
said is right.
Okay. So it's
Yes, I
C double bond O. Then at the end, at the other end,
it's eight.
it's H. that is an aldehyde. Then a ketone. How does a ketone look?
It's C. Then you have a C. Then the middle C has a double bonded O. Then you also have another C.
Good. So for aldehydes, this is what we have. Just a quick reminder, aldehydes. The C that is double bonded to oxygen is actually one of the C's at the end, right? And then for a ketone, the C that is double bonded to an oxygen is one of the C's in the middle of the chain. So sometimes your books will say R dash and R, but those R's just represent the main chain, or to say the chain just keeps on continuing on the other side. So in this case, I'll just have one R in this side, and that's it. That is the functional group of aldehydes and ketones. And you can see from these two molecules that they are closely related, or they are similar. This is what I call functional group. Functional isomer friends. Isomer friends. I'll explain what I mean by that. What I mean is that if I move the double bond O to another carbon in the chain from the carbon that is at the end, then I have a ketone. But the molecular formula is still exactly the same, and the molecular mass is still exactly the same. So that is a functional isomer. And if I take the double bond O and move it to the end from a ketone, then now I have an aldehyde. So those two, if we move the position of the functional group, we have functional isomer. Another functional isomer friends are carboxylic acid, and esters. If ever you see questions on, maybe they give you an aldehyde and then they say, what is the letter that represents a functional isomer? You know, immediately looking for a ketone. And then if you have a carboxylic acid and then they're looking for a functional isomer of that, you know that it should be an ester. So you know that carboxylic acid will look like this, double bond O, and then there's OH at the end, and then esters will be double bond O, and then there's actually O, and the chain continues like that. So you can see that we can move around, we can move this double bond O and oxygen around, and we can have another different molecule. That's why we call them functional isomer. But you also remember that by just moving the position, I might not even change the functional group. And that brings us to like position isomers. Like if I move this functional group OH from one of the C's to another, then that still becomes alcohol. It just becomes a different kind of alcohol with a different IUPAC name. But if you move positions of functional of molecules that can become another one, then that is called a functional isomer. Okay, that's just a quick reminder. We'll have those like pop-up tips or reminders usually, because these recordings will be like I'll say they'll not focus on the same paper or the same topic. We'll just do a little bit of everything just to prepare you for the exams. Then you can just come back and use them to prepare. Okay, then 3 point. Okay, by the way, yeah, this is boiling point on the Y, and then there's molecular mass on the X, and then we have P, R, and S here on our graph. They say the curves P, R, and S. Oh, I didn't finish actually reading the question. Carboxylic acids are also represented there, and primary alcohols are also investigated. So here's your assignment. When you read these statements, you should pick up these clues that they give in the statements, or this important I'll say, I don't know, important information there in the statement, like primary alcohols. It cannot just be any alcohol that you'll be dealing with here. It should be primary alcohols. And you will remember what a primary alcohol is compared to the other two types of alcohols. Anyone who remembers what a primary alcohol look like?
It's
Um,
bonded to one carbon, so it'll be at the end.
Okay, yep, that is correct. So I'll just say this other side, it's just the chain continuing. Then I'll stop there. Secondary alcohols will just be in a middle chain that is only bonded to two other carbons. Then tertiary will be an alcohol that actually has a branch. So in other words, it's going to be the OH is going to be found on a carbon that is already bonded to three other carbons. Okay, that's a tertiary alcohol. But in this case, we focus on primary alcohols, and we'll see why in the questions as well. Curves P, R, and S are obtained. All compounds are all compounds used as straight chain molecules. That's also important. They are not chained. Whether it's an aldehyde, it does not have any chain. It's a straight molecule. Okay, then they give us the graphs P, R, and S. Then they say define boiling point. That's fine. Write the conclusion. You guys will go and look at that, because I just want to go to the questions that later were asked. Explain the answer. Curve R represents the alcohols. Then I guess we can start here, because 3.5 also is about curve R. Curve R is for alcohols. I'll just highlight curve R. Remember that these alcohols are primary alcohols and they have straight chains. Then they say which homologous series is represented by curve S. Okay, so you see now what they do is they intentionally specify that the one in the middle is an alcohol. Then you should then identify that P and S, or which homologous series P and S will then belong. In other words, a molecule that has a molecular formula about this much, or a molecular mass, sorry, compared to another molecule that has the same molecular mass, but these two have two different boiling points. You should be able to identify if this is a carboxylic or whether it is an aldehyde. Same applies to this one. Is it carboxylic or aldehyde? Which one will have low boiling point between aldehydes and carboxylic acids?
Aldehyde.
Aldehydes. Okay, so aldehydes will be represented by those, and carboxylic acids will be represented by that one. Okay, cool. Then we move on. Explain the answer to question 3.4.1, referring to the strength of intermolecular forces. You know how to explain this one. So you have to refer to the number of hydrogen bond sites that you can have. You probably know what I mean by that, so you go and review your notes about that. Intermolecular forces related to organic chemistry. I don't think it's a long topic for this, so I'll also try to send you some notes on that. Then 3.5 says for curve R, write down the following: the molecular mass of the compound with a boiling point of 97. And that could be useful for our answer in 3.5.2. So we'll answer that one first. We'll go and look at the boiling point of 97 on curve R, right? So 97 will be, let's see, this is 50. Then this should be 75. Then it means we have 80, 90. Wait, we have 80 and 90. Okay, no. 75 should be right here in the middle. Then 80, 90, 95, 97. So about right here. Then I can just go and check what the molecular mass will be. Okay, according to this basis, then should be 60 at the middle between 50 and 70. Okay, so the answer we're looking for is 60 grams per mole. That's the molar mass of that compound that has a boiling point of 97 degrees Celsius. Okay, if you have any question at any point, do ask. So the compound we're looking for is having 60 grams per mole. Okay, that's just reading the graph. And then 3.5.2, which is actually the question. Okay, before that, I want to answer the question that we have. You can go ahead. Yes.
Can you please repeat the question? What is it? The question that we're doing right now.
3.5.1.
Yeah. Can you please repeat?
You mean which question? 3.5.1 or?
That one, 3.5.1. Like, please repeat on how to identify the
Molecular mass. Okay, so the molecular mass, look at this. The question says for curve R, so it means we're going to focus on curve R, the one I just highlighted. Write down the molecular mass of the compound that will have a boiling point of 97 degrees Celsius. So just go on the table. You go and look for 97 here on your boiling point axis. And then 97 will be just about there, almost at 100%. Then you go and draw a line where it intercepts curve R. Where it's going to cross curve R, you're just going to draw another line that will go all the way down. And then you can read the value of the molecular mass right there. So if they were saying maybe what is the molecular mass of curve P that will have a boiling point of 200, then I'll go on 200. I'll draw a line on 200 where it intercepts curve P. Then I'll draw another line that goes straight down. We'll be using a ruler then we can see that it's about like 115 maybe grams per mole, right? Or they can give you the molecular mass 90 grams per mole for curve S. Then what is the boiling point of that? So it's just basically reading the table. Then you pick out the number there, just counting the blocks, the spacing, and then you can be able to identify what value you have. Okay, but the issue is with this one, and I think it's a good question. It's a very good question. For curve R, write down the IUPAC name of compound in question 3.5.1. Okay, what we already know is 1. This is a primary alcohol. And it also has a straight chain. So you don't have to worry about any branches. Now they're looking for the IUPAC name. It's a question that sounds unfair, but you can actually work it out. And once again, the importance of these lessons are not to actually teach a specific question or teach how to answer a specific question. And also when you're revising, don't try to learn how to answer a specific question. Try to develop skills to be able to solve any question. By solving this question, we are developing a starting point. Where do I start with this kind of questions to actually tackle any other question? Because you see, if you leave spaces, then you didn't know where to start. And it begins where you start. If you know where to start, you can actually tackle the whole thing. So let's see where we can start. I already started the question. This should be a primary alcohol and it should have a straight chain. Then the second thing that comes into my mind is, okay, I have the molar mass of this thing. The molar mass of this alcohol is 60 grams per mole. So how can I work out the IUPAC name? And before I can even have the IUPAC name, I should work out maybe the structural formula. Maybe I can get the structure or just the formula or the number of carbons in that chain, because if I know the number of carbons, then it means I can be able to find the IUPAC name, since I know it's a straight chain. So I don't even have to worry about if one of the carbons is on a branch and stuff like that. Okay, so every carbon that is present in this molecule will be part of the same straight chain. Then what I do is I'm looking for basically the number of carbons. That's what I'm thinking in my head when I look at this. And if I can find that, then I can work out what the name is. So the first thing I want to do is to figure out what kind of molar mass or what kind of molecule represents primary alcohol. And for that, you have to go back to the general formula, or the general, it is the general equation for for primary alcohols. And to see that any general equation of any homologous series, you just have to draw it out. You don't even have to draw many carbons. I can just draw this 2, and I know that this is a primary alcohol, and then I can say, okay, the general formula of that will be CN, and then my N in this case is 2. Then I count my hydrogens. It's 1, 2, 3, 4, 5, 6, which means it has to be H2N plus 2, right? And then there's also oxygen, so I have to also have oxygen right there. Let's see, does this make sense what I just did here? Yes?
So can you say CnH2n plus 1 OH?
CnH2n plus OH.
1 times OH.
Okay, wait, let me write it down. It's CnH
2n plus 1 times OH.
or plus 1 OH. Yeah, that works. Yeah, that also works. Okay, so we can use any of those, but what we are coming at is, let me put this on the side, then we can, you can go ahead and check if that also works, and it will work, because that is also a general formula for the same thing. Just depends on how you think about it. And I think this one will be the most correct, because it also shows you the OH, which is a functional group for alcohols. Okay, but for our purpose, we're just looking for the number of N's and the numbers that are multiplying everything. So in this case, when you have this, now you know the sort of formula you expect, because that's how you get to molar mass. From a formula, you get to molar mass. So since I have the molar mass, it means I'm solving for n. And if I know n, it means I can know how many carbons are in a straight chain. So here's what I'll do. The molar mass of this alcohol is going to be C, which is the molar mass of C is 12, but this 12 has to be multiplied by some number, and I don't know the number yet, so I'll multiply it by n. Then I'll say plus, because every time we do molar mass, we add in between molecules. And then we have H, and this H has a molar mass of 1, but I have to multiply by this number, the subscript of H, which in this case is unknown, but I know it's represented by 2n plus 2. Then I'll go and say plus the molar mass of oxygen, and there's just one oxygen all the time, so I'll just write 16. I don't have to multiply by n or anything. Then I substitute the molar mass because I know the value of that is 60. So 60 is equal to 12n. Then it's just basically solving for n from here on, plus 16. So let's see what n is equal to.
N is 3.
N is 3. So now we can identify the IUPAC name of this, because we know that in the main chain we have C3. So you don't even have to go on, but we can. H will be H8, and then oxygen, or I can write it using the Tavos formula, which will be 7, I think, OH. Yes, do we have a question?
Yes, it's from Ivan. Can you
Yes.
please repeat the calculation?
The calculation. Okay, so let me quickly repeat it, but again, it's gonna be available in the recording, provided that my laptop doesn't switch off. So I'm just like crossing my fingers. Okay, so we have the molar mass. That's the first thing we know, or the first thing that we found from 3.5.1. So knowing the molar mass, what should come into your mind? And this is like, again, a plan for this specific question, but it should set you up for any other question. When I see molar mass, what should come into my mind is I need the formula that I used to find the molar mass, but I don't even have the formula, so I have to write the skeleton of the formula, or the general formula that gives me a primary alcohol. And that is, like you saw, what I did is I drew any example of a primary alcohol just to count everything, so that it can help me write the general formula. And I ended up writing this one, but maybe this is not the one in your book. The one in your book might look like this. So either the two will work. So you write the general formula, and then you go and say, okay, if I'm finding the molar mass of that, it means I have C. Let me highlight the C. Cn, that n is a number. It's any number from like 1 up to infinity, but you can't really reach infinity. But it's 1, 2, 3, 4, or 5, or anything. So I'll just write n so that I can solve for it later. Same applies to the hydrogen part. It's gonna be, the number is, what stands for the number is 2n plus 2, and that is figured out from the actual formula of any primary alcohol. It's gonna have 2n plus 2 hydrogens, and it's gonna have 1 oxygen. Any primary alcohol have 1 oxygen. So that's the general formula. Then from there, I just simply go and calculate the molar mass of that skeleton formula. The molar mass of H is 1. The molar mass of oxygen is 16, and oxygen is not multiplied by any number on the bottom, so I just leave it at 16. Carbon is multiplied by n, so it's the molar mass of carbon, which is 12 from the periodic table, multiplied by n, and that n is what we're trying to solve. Then if I substitute my molar mass which is 60. When I calculated, or when I found the value of from the graph, then I just simplify the side and I find n equals to 3. Therefore, I know that a primary alcohol that has 3 carbons, that's just simple. It's just propanol, or propan 1-ol. Yeah, actually that's a good thing that I actually remember, that we should specify the location of OL, because if it's a 3 carbon molecule, an alcohol group can be there or it can be there. If it's here, then it's the same as being there. So I can say it can be in the middle or it can be at the end. So we have to specify for propanol. It can't be propanol, it has to be propan 1-ol or propan 2-ol. If it was ethanol, then it means it can be at any of the ends, which makes it ethan 1-ol, but we can't specify because it doesn't change, so it's just ethanol. But from propanol up to anything else, then we have to specify the location. Okay, I hope that makes sense. So that's how you should have figured that question out. But yeah, what we are
Yes,
doing
thank
is
you.
learning. Okay, good. All right, thank you. All right, I was a little bit slow on that one. I see we have like 22 minutes left. But again, we're just learning how to tackle question, not how to answer specific questions. That's why I want us to do Q&A, because if you tried a question and you couldn't get it right, I mean, you can have the memo, right? But you see what is in the memo, but you don't understand how they get to that, because the memo doesn't explain how to get to the answer. It just gives the answer, and they expect that the learner, if the learner understood, they'll write something similar to the memo. But if the learner didn't understand, then they'll not write anything similar to that. But the memo will not explain. So I'm not saying don't rely on the memo. I'm saying if you don't understand something, even though you have the memo, do ask so that we can explain it. Okay. All right, let's go through this one quickly. Consider the cracking. If you remember, cracking is the breaking down of longer chains into smaller, much useful ones. So cracking. Every time you get to a question, guys, you break it down. And then what I remember from cracking is that it's going to produce 2 kinds of molecules, which are what and what?
What's that? Kanawariki. Yo, I forgot. But I know what it is.
Yeah.
I know, for example, you have methane and ethyl. I think ethyl, man. Methane and ethene or ethene or whatever.
Yes, you are right on the money. So it's gonna be always an alkane or a bunch of alkanes and then a bunch of alkenes, right? Alkanes
Yes, sir.
and alkenes. Yeah, that's what it is. So when we are cracking this molecule, I don't even know the name. It's C16H34, and you should see that this is. Oh, by the way, cracking, we can only crack alkanes from our syllabus at least. So whatever you're starting with, it's an alkane, which means the general formula is CnH2n plus 2. Okay, you have to remind yourself of this general formulas as well, guys. Therefore, now we look. One of the products is C6H14. Is this an alkane or alkene?
It's alkane.
It's an alkane. Okay, did we have a question? I think I had a sound on my side.
Okay. No.
Okay, so that's an alkane. So we know that one of the products, at least this or this, should be alkene, or both of them should be alkenes, but we'll see. Then going to this one, No, C6 HX. C6 HX. So what could be this? X, and then we can go to this one, CY HZ. The very first one to figure out is the Y.
Y.
Yeah, that's the easiest. So what is the value of Y?
2,
It's how much?
2,
2.
yes.
Okay, do we both all agree with 2?
So I get 4, say.
You get 4. Okay, let's see. Lubabalo, what did you get? The value of Y.
Yeah, it's 2. She's right. It's 2, say.
Okay,
What
it's
is-
also 2.
It's 2.
All right. Yeah. So we're going to add this 6 and 6. That gives us 12 already. Then it means we are remaining with 4. But this 4, there's 2 of CYHZ, which means each should have 2. Yeah, so that's correct. It should be 2. So I see why you said 4. That's close. That's the 2 because it's 2 of them. Okay, then now we figured out the Y. I'll just erase that and put 2 so that we can think about X and Z. Okay. Then which one can we do next? What are we thinking at this point?
We can do X.
Yeah, X.
Okay. Then what will be the value and how can we actually figure it out? Don't forget to do this trial and error. Try a value. If it doesn't work out, change it. That's the only way to solve this kind of questions. So let's try, let's say this is an alkane, and then we'll try, if it's an alkane, what will be the value of X?
If it's an it will be 12.
It will be 14 actually.
Yeah, 14, yes.
Yes, so
14.
let's try 14. If that's 14, then what is Z?
Then it will be 28.
So this one has to be
No,
an alkene
yeah.
by force, by the way. Sorry to interrupt, but Z should be, or C2H Z should be an alkene. So if it's not an alkene, then it means we made a mistake. Okay. So what was the value? It's gonna be 34.
What I did,
Oh yes.
I said, so what I did was 34 minus 40. I got 20, right?
Mm-hmm.
Then I went to the alkene part,
Yes.
which is 2CY. I get my Y is 2.
Mm-hmm.
So then, I said since my age is 20 and age has to be X and Z, ne?
Yes.
I tried to divide the 20, ne?
Yeah.
Then I said the last compound.
Mm-hmm.
I said 2 times 5 is 10. Then I'm left with, what did I do? I was actually wrong because I took the 5, then I was left with 15. But I didn't take the 15, I took the 10. So I missed the 5. But now I'm hearing what you know I'm wrong when I'm saying it.
Oh yeah. There's someone who raised their hand. Go ahead.
There was a message.
Oh, it was a message. Yeah. What does it read? Can someone just read for me?
They said it was saying Z is equals to 3.
Okay, yeah, thank you. So in our assumption now Z is equal to 3, and that's because we have a condition. If this is an alkane, it means Z should be an alkene, because we have to have alkanes and alkenes. So this means now Z has to be 3. That's the only number that is left after we minus 28 from 34. So we get 6, divide that by 2, we get 3. And 3 doesn't work out. I'm sure you can see that if I have C, and then I can't just have 3 hydrogens, even if it's an alkene. There's something missing. So this means X is definitely not 14. So this also means X is not an alkane, it's an alkene. So that's how we figure out that X is an alkene. Then if X is an alkene, then it means it should have 12. It should be 12. Because formulas for alkenes are this. So if that's 6, that is 12. Okay, then if that is 12, it's still trial and error, but hopefully now we get it right. Then we work out what Z is equal to by minusing 14 and 12. What do we get?
If we do what?
If we minus 14 and 12 from the number of hydrogens, this is the hydrogens.
20 minus.
Because remember, 14 is already given, 12 is what we figured out, and we are looking for Z.
It's 8. 34 minus 40 minus 12.
8. Then because the molecule itself is multiplied by 2, then we have to divide that by 2 in order to find the value for one of them. And that should give me 4. So I say Z is 4, and then I see if that is possible. And indeed it is possible. I can have 2 H's and 4 hydrogens, and that should mean that there's a double bond in between, making this one also an alkene. Okay, and that's how to work out that. It's 3 marks, which means you have to be quick in doing so. Don't want to waste marks on a 3 marks question. But if you already know what to do, you know how to be quick. Okay, so at the end of the day, Y is 2, X is 12, Z is 4. Okay, any question? Lubabalo, are you also following? Okay. I remember if it was a little bit too quick, you can always go back to the recordings. Okay, so we already got that one. Then let's see. Compound C6H14 undergoes complete combustion. Use molecular formulae to write down the balanced equation. Okay, combustion should really be 3 marks. It's just balancing.
Yes.
Yeah. Okay, let's see if maybe you guys remember. Let's say, what is the other reactant for combustion?
Oh, say I don't know.
Okay, let's have what is the other reactant for combustion?
Oxygen.
Oxygen. Yeah, it should always be oxygen. If they say combustion, anytime they say combustion, you know the other reactant is oxygen. It's whatever you are combusting plus oxygen. And then Lubabalo, do you know the 2 products of combustion? No. Okay, Liseri, do you perhaps know? Maybe by just looking at the reactants, maybe.
No, say.
No. Okay, Letabo, do you happen to know?
Carbon dioxide and water.
Yes. Okay. Guys, hopefully you don't forget this one, because I think in most question papers that I've seen, they always have combustion. It's carbon dioxide and
Wait,
water.
is it
Yes.
always carbon dioxide and water?
Yes, always. It's always these two. And oxygen is always one of the reactants. So if you have to remember that one, then yeah, you can go ahead and just remember it that way. Then the last thing to do is to balance. Balancing can get a little bit complicated, but it should be, for you guys, grade 12, it should probably be simple. The first thing I want to do when I balance, I look at the things that are PS1s, both sides. Okay, what? How did that even happen? Okay.
Everything is erased.
No, it's not. It just jumped into another page. Or, yeah, it jumped into another page somehow. Maybe I pressed something with my phone on, because it's on the keyboard. Let me just go back. Where was I? It jumped into term 3 for some reasons. But okay, here we go. And then I accidentally pressed on undo. But yeah, we are back now. So you look at the one that appears once on both sides when you balance, and that's carbon and hydrogen. But carbon is arguably the easiest. So I'll just say 6 there to balance this 6. Therefore, I go to the second one that appears once, or that is simplest, and that's H. So I already have 7. I already have 14. This side I have to multiply by 2. So it should be 7, isn't it?
Yes.
Okay, then now we look at the oxygen. You go and say 7 times oxygen, that gives you 7, and then you say 7 times 2, that gives you 12. Add 7 and 12, that gives you 19. But you already have a multiplier of 2, therefore it should be 19 divided by 2. So that when you multiply, now it's 19 this side, it's 19 this side, it's 19 the other side.
Yes.
Alright, that always happen. Not always, sometimes happens in combustion. And you can combust anything. Like it could be like a primary alcohol or anything like that. 8OH plus oxygen. And you have to work out the balancing. Okay, then obviously we have a fraction, which means we have to get rid of that fraction. We have to multiply by 2 all throughout. Then it should be 2C6 H14 plus 19 over 2 by 2 is just 19. O2 is 7 by 2 is 14. H2O plus 6 by 2 is 12. CO2. And you can go back and verify that everything is balanced, and it should be balanced. Yeah.
Yes, it is.
Yes. Okay. That's how to do combustion. You just need to know if this didn't make sense, let me know before I move on. Because you always have to do those kind of things. Or you can just go and watch the recording. Okay. Then again there's this question. Let me just copy it and paste it somewhere else so that we can look at it. So if we had time, we were going to look at the other ones for work energy and power, but we'll do that. Or again, I said we should have another lesson either tomorrow or Thursday. So tomorrow.
Because
Okay.
on Thursday we have maths.
Oh, okay. All right. Yeah. So we'll decide on the
Say, I
time.
won't be available.
You won't be available tomorrow.
I'll be
Okay, we'll see another time that we can use. But let's look at this one. Consider the equations for reaction 1 to 3 below. A and B represents organic compounds that are, again, they give you this clues, Easter eggs, or whatever you call them. X is an inorganic compound or product. So this one is inorganic. Do you know what they mean by inorganic? Or maybe you don't have to overthink that. It's just something that doesn't look like that. These are organic. These things are organic. This is not organic. Water as well is not organic. So basically looking for something that does not have like C's, H's, and oxygens when they say it's inorganic. Okay. Then write down definition of positional isomers. Anyone who remembers how to define positional isomers?
They have the same molecular formula, but they are put in different positions.
Molecular formula. Yes, same molecular formula, different position of functional group. And they also have the same homologous series, by the way, functional group, I think. Same homologous series or functional group. Just the difference is the position where that functional group is. I already made an example of that with the alcohols. If we move I'll just give this example. I have a ketone. Once again, I move the functional group to this other carbon. I still have a ketone. So that is two functional groups. Maybe I have to add another C so that they are different. So they are functional isomers because I move the functional group, but it doesn't change the fact that it's still a ketone. It's just pentan 2-one from pentan 3-one. But if I move it to all the way this side or this side, now what is it? If I move it all the way to the end,
It's a pen 1-1.
pentanal,
Okay.
right? Because it's aldehyde, isn't it?
Oh, okay.
Yes, and remember for aldehydes, the functional group double bond O is always at the end, so you never specify where it is, because it will always be at the end, right? So yes, so these two are positional isomers, but when you combine something that will change the name, it's now a functional isomer. Okay, they always catch people on those kind of things. All right. Okay, 4.2.2, the type of reaction represented by I. Okay, once again, this usually in question 4 you see the flow charts and the flow diagram. Some people love those, but in this case they give you like 3 reactions in a table, but we can also fill them up. For example, the first thing you want to do every time you get to organic chemistry, you draw out the molecules. So I'm going to draw out that one quickly. C, the first C has 3 other hydrogens attached to it. The second C has 2, so it means it's here and here. And again, guys, this is trial and error. So if you don't get it right, try again. You can't draw it right exactly like the first time, unless if it's just luck or you did this a lot that you are experienced. So that will look like this. You can count the number of C's is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Then the C in the middle, they all have 1 hydrogen attached to them. And that should mean to you that there's a double bond right in the middle. Okay. If there was no hydrogens, then it means there will be a triple bond in the middle. Okay. Then now I know what kind of molecule I'm dealing with, and I have to add hydrochloric acid. And by the way, you can see that this is a halogen. So we are basically doing hydrohalogenation. Hydrohalogenation, which is a type of addition reaction. How we know it's an addition is because we are going to destroy a double bond to form all single bonds, and the molecule is going to look like this. So the question was, what is the difference between molecule A and B? And let's see, we have to get two products. The first one is probably going to look like this. Just be quick drawing this because of time, and then we'll decide what happens. The first thing I know is that now it's going to be all single bonds. Then you can apply Markovnikov's rule to this, but I don't think it's gonna change anything. Or is it? What will Markovnikov rule say about where H or Cl is going to be attached?
Cl is going to.
Yes?
With the one that's like the hydrogen.
Wait, let me do this. Let's say we can attach it at A, or maybe let's say at 1 or at 2. Where will chlorine go? 1 or 2?
2.
2. Okay. Why?
Because it will have the shortest, I don't know how to put the English, but it's on the shortest one. You know, when we write the IUPAC name, then in Mori, you start with the chlorine side.
Yeah.
And if you have the chlorine and you have a methyl group, you have to start with the chlorine side. So the chlorine has to be on the side where when you write it's a shorter something. I don't know the word for it.
Okay, all right. Do find that where the reference is, like if it's in your textbook or something, then send it in the group as well. But what matters is that you're going to end up with two products that are similar. The only difference is where the chlorine is going to choose to go. In this case, the chlorine has two options. It can either go on the green line or on the blue line. That's why you have two products. Or I can have chlorine going on that green line like this. So that's compound A and B, just like that.
So what I'm saying is, they said, okay, it's not in the textbook, but my teacher said that when you write your IUPAC name, when you add the numbers,
Yep.
Sometimes this is a simple one, but if you have a methyl group, then maybe they add up to. Basically, it depends on the chain that you chose. If the chain that you chose, then the numbers add up to maybe 8, then the other one add up to 6, then you must use the ones that add up to 6, if you get what I mean.
Is it, what is this? I did this in first year chemistry. Formal charge, is a formal charge?
Yeah, something like that. I think so.
Okay, yeah, that's a little bit complicated, but I'll tell you what, usually they'll give you something that is easier to figure out, or you'll have a major and a minor product. In this case, it's all going to depend on formal charge, which will not even go into, but just choose any one of those to be your A and any one to be your B. And I think you'll never see like a question like this that can have two positions where Markovnikov's rule won't even apply. A lot of the time they'll give you a question where you can use Markovnikov, because you don't really do formal charges in grade 12. But anyways, if you know that, that's an advantage, definitely. But don't worry about that if you didn't know about it. But yeah, that's the two products that we have. Then the issue may come on this kind of question. They say, draw the structural formula of B. Now you don't know which one should I say is B and which one should I say is A. And yeah, this is where things become difficult because they didn't even specify which one is which one. So I'll say just go and draw any of the two there. If ever you get a question like that, it's so like it's an unfair question, to be honest. But draw any one of those. Okay, formula of X, you can check. I mean, we don't have time anymore, but they're taking A, like they're taking this, and then it's now going to have water added to it, and then there's also heat. You know that A is a haloalkane because it is a halogen. So it means I'm basically performing halogenation, which means I'm adding water to a haloalkane that will give me an alcohol plus a HX, I'll say. So if you can draw out this, you have to draw out this, and then you can figure out what X is going to be. Therefore, you can draw out this one and this one are the same. So you draw out the same thing, and then they come back to the one I highlighted in yellow again, plus water. So it's basically still a flow diagram. They just use the different kind of representation. But yeah, if you can take 2 minutes just to show the complete flow of this, I'm gonna take I'm gonna take A, and I'll show how that table will also be a clue for you deciding which one A is and which one B is. I'll show you what I mean by that. So we go and take A. At this point, we're not even sure that this is the correct A, but we have to react it with water to become that other thing there. So see what happens now. If I react this with water and heat, and this heat is a condition that, by the way, represents heat. It's a reaction condition for halogenation. Therefore, I'm going to draw out, or I can just do copy and paste just to save time. I'm going to draw out the product, the one with OH in the middle. So paste that there, and then go ahead and add OH where chlorine should have been. OH, or however way you show it. Therefore, the other product, if you check here, if I'm putting this in water, and from the water, let me just draw the water as a structural formula. I'm putting this in water, but from water, I'm only taking the OH and I'm putting it there. So this H will combine with the Cl to form HCl. This is the HX that you see in your textbook for halogenation. Therefore, what do we now have is that molecule. Then look at this. This gives you a clue of which one A was from the beginning. If you look at the product, this product, I'll now highlight it in blue so that you can see it. This one. It shows you where the position of OH is. And you can see it's on this carbon that is closest to the last carbon, which means A should exactly be the one we chose there, which means B should have chlorine in the middle. That's the only way you can figure out which one is really B and which one is really A. So in the memo, you expect to have only this one, and they may not even accept this one for structural formula of B. I don't know if we are all on board. Are we all on the same page, or was that too quick? Hello guys, are you still here?
We are fine, sir. We are fine.
Yeah, we are fine.
Okay. Yeah, then that way you can see that A should actually have chlorine at the end, or at the C that is closest to the end. Therefore, on reaction 3, they just have that same molecule, and they are removing water now. So if I take that and then draw it here to represent reaction C, or reaction 3, I mean. And you should know the reaction conditions, by the way, for this. So it's going to become A again, but at this time it will have a double bond. So I'll go all the way to the first molecule and just copy that and paste it there. So it becomes this plus water, because we removed water. Okay. All right, there we go. Then you identify the reaction conditions. Again, I just forgot. I have to send you like a summary, but I'm sure it's there even in your books, where you'll have all your reaction conditions. I wrote reaction conditions as RC in my notes. So whenever you see RC, it's reaction conditions. And you can see also in the questions, they do ask a lot of questions on reaction conditions. 2 terms, no. In this case, there's no questions about conditions, maybe, but a lot of the time they'll even have like 7 marks on conditions. So just be informed about that. Okay, guys, I will end here for today. Next lesson, we'll continue with the other questions I've received from you. Others also send questions so that we can work that way. Okay, yeah, that is it for today. I'll see you either tomorrow or Thursday. We'll see. We'll just see.
Say,
Yes.
if we have class tomorrow, say, can you make it much earlier? Like, come on,